Today's lesson is on earthquake prediction. And yes, there may be a way to predict earthquakes. And I'm going to tell you a story in a little bit here that may give you some hope. But a lot of money is spent for, building buildings that withstand earthquakes instead of trying to predict them. So for prediction, most earthquake prediction is centered around precursors. Precursors are just things that happen before the earthquake and are related to the earthquake, but they don't cause the earthquake. Just similar to the precursors that we had for volcanoes. So instead of me just listing the precursors, what I want to do is I want to read to you a story about a very successful prediction. And I'm reading this story. This is from the book Earthquake Ready by Virginia Kimball. I want to make sure I give her credit for what I'm reading here. And as I go through, you can write down some of these precursors that they noticed. So scientists and historians have been observing and recording earthquakes and their effects for about as long as they've been recording anything at all. The Chinese are unequaled in this field. Whereas written accounts of earthquakes in the United States go back only 200 or 300 years, Chinese records date back as far as 3,000 years. It is no surprise, then, that China should have taken an early lead in earthquake prediction and warning. The large number of stone houses, poor construction, and overcrowded conditions have contributed to high casualty rates in earthquakes there. They were confident that with enough information, earthquakes could be predicted, and they were willing to undergo the inconvenience and evacuating their homes and the chance of avoiding the devastating human death toll recorded with these past earthquakes. The Chinese political and economic system, which was communism, allowed for trial and error in developing an earthquake warning system without the tremendous economic and legal entanglements that complicate the system of prediction and warning in the United States. We'll talk about that at the end. Disturbed by the news of so many deaths caused by a series of 3 earthquakes in March of 1966, China's Premier Zhou Enlai responded by ordering Chinese scientists to develop an earthquake prediction system. Seismologists in China analyzed data from historic records, instrument readings, and a large number of observations reported by scientists, farmers, and other workers. There was widespread attention to unusual animal behavior, so go ahead and write that as one of your predictions, or precursors, the unusual animal behavior, and changes in the water level of wells, so you can write that one down, as precursors of earthquakes. During the 1970s and early 1980s, the whole country was used as an earthquake prediction laboratory, and scientists received more criticism for not issuing a warning than for a warning of an earthquake that did not occur. Chinese greatest success in earthquake prediction was the magnitude 7.3 earthquake of February 4, 1975, in the city of Haicheng, in northeastern China. The decision to keep a close seismic watch on the area was made in 1970 on the basis of a pattern of small earthquakes with epicenters that seemed to be moving toward the Liang province, where Haicheng is located. So you can write down small earthquakes or foreshocks as one of your precursors. The local seismic observatory noted changes in the Earth's magnetic field, write that down, and a rise and tilt of the Earth's surface during 1973 and 1974. Other precursors were noted in 1974, an increase in the number of small earthquakes, well water becoming muddy, an increase in radon gas in wells. You can write those down. By early 1975, reports from zookeepers and farmers indicated unusual animal behavior, listless tigers, fish jumping from rivers, pigs refusing to enter the size. On February 1st, the number of unusual reports began to escalate. Well water levels rose suddenly, hot springs stopped flowing, frogs were observed jumping through holes in the ice, animals refused to enter their folds, and a series of earthquakes was noted in a previously quiet area. It's called a seismic gap, which we'll talk about. Scientists met, compared notes, and reported to civil authorities. At 2 p.m., this warning was issued. There probably will be a strong earthquake tonight. We require all to leave their homes and animals to leave the fold. Also to move the weak and old. There will be 4 movies shown outdoors in the city square tonight. And city squares in China are huge. Think of like Tiananmen Square in China or like Red Square in Russia. Big areas where they can put hundreds of thousands of people. Despite bitterly cold weather, the people cooperated. Patients were moved from hospitals, families, vehicles, and farm animals were moved out of buildings. 5.5 hours later, the large earthquake began, caused widespread damage, collapsing up to 90% of the structures. There were very few injuries among the 3 million people who lived in the area because they had left their buildings to move to open areas. So an amazing success, 3 million people and just a few injuries because everybody had gotten out before the earthquake struck. They were able to predict it. They've had other successes, but also other failures. 17 months later, there was a strong earthquake in the city of Tangshan in 1976. 243,000 people died, and they had very few precursors, and it didn't issue any warnings. So, um, so prediction may be likely or may be possible, as the Chinese have proven, but it certainly isn't happening all the time. So here are some of the precursors that you hopefully wrote down as I was reading. You should have more than this. One that we didn't mention there, it's more a modern one, is this dilatancy. Basically, you're looking for micro cracks or fractures in rocks, and they lots of times will test it by sending electric current through rocks and seeing if that electric current gets disrupted by little fractures. Basically, we think that the pressure is building up so much between those two sides of the fault that are ready to break that a lot of times the rocks fracture just a little while before the earthquake actually snaps them. Okay, so lots of things that you can use to help predict, lots of precursors. Um, so why don't we do this? So think of it in the United States especially. Why don't we issue predictions? If maybe we could, okay, maybe we could predict them. Why don't we issue warnings? There are a number of reasons. First thing, economic losses. If you issue a prediction, businesses are going to close. National Guard's assembled. People aren't going to jobs. If think of like Los Angeles, the big cargo ships that are out in the ocean aren't going to be unloaded. Millions and millions of dollars would be lost. Um, in the case of Los Angeles, millions of dollars an hour would be lost for every hour that Los Angeles was shut down. So it'd be a huge economic loss if it happened. You think of the story that we heard about in the volcano unit in California, where they predicted that a volcano was going to erupt during the ski season. It shut down the ski season. When it didn't, when the volcano didn't erupt, people threatened to kill the people that had issued the warning because it destroyed their lives. All right, all the economic loss from that whole ski season was gone. So the economic loss would be huge if we issue a warning. Panic, traffic jams, accidents, people trying to get out. People could die. And then what if there isn't an earthquake? Looting and rioting. You say that there's going to be an earthquake. Some people just take that as an opportunity to take advantage. And they break into stores, they steal TVs and things like that. So looting and rioting would be a problem. And again, what if there isn't an earthquake? And then I had that liability issue, and I kept on saying, what if there wasn't an earthquake? So if something goes wrong, someone must be held responsible. In the United States, there's lots of lawsuits. Okay, so all those economic losses, but there isn't an earthquake. Who's responsible? Maybe somebody dies in a traffic jam trying to get out of the city, and there wasn't an earthquake. Who's responsible? Maybe your store was broken into and somebody stole all the televisions, and there wasn't an earthquake. Who's responsible? So this liability issue is huge in the United States. Some other things, monitoring faults, seismic gaps. I mentioned that a little bit in the reading. I just wanted to point out because it is a big thing. It's an important thing to look at when we're looking at earthquakes. Basically, what a seismic gap is it's a part of the fault that has not had seismic activity for a while. Okay, if it hasn't had seismic activity for a while, that means it's a good candidate for seismic activity in the future. This is an example, is diagram for Loma Prieta earthquake, so San Francisco 1989. And you can see this is before the October 17th earthquake. You can see all these are different different focuses of the earthquake. You can see lots of all these red dots. And then, but not as many in this Loma Prieta gap. Then the earthquake happened, and you can see all these kind of foreshocks, aftershocks, everything happened in this Loma Prieta gap. So it's a very quiet area of the fault. That's where you would expect the next earthquake to be. That's really it for predicting earthquakes. You're mainly just looking at precursors and trying to predict when an earthquake might happen.